You can see the start button has been energized here, and once this one is energized, the timer starts operating. And once here we divide, we can see 20 divided by 2, we are getting 10. 10 is stored here, and the bulb is actually giving us. Hello guys, welcome here to another session. And in this session, I'm going to take you in the first realistic example whereby I will be taking you through a programming example of blinking a light. So everything is going to be physical, where we are not going to deal with physical wiring and whatever we shall do with simulation to have a realistic view of what you are actually doing. So by the end of this video, you will be sure of what you can do with the PLC or maybe with the programming environment. So in this example, what we are going to do, we are having a case scenario of blinking an light emitting diode, that is a LED bulb emitting it, and then you can either increase the rate of blinking or you can decrease the rate at which it is blinking. So apparently in that kind of a system, you're going to be having three buttons, one for start and stop, that's one button. The second button is going to be for increasing, and then the third button is for decreasing the rate at which it will be lighting, on and off, on and off, and on and off. So in your mind, whenever you get a PLC case, you have to first have a vision, how it is going to be looking like. What are the buttons I have to place maybe to respond with the PLC? If I'm designing a control panel, what are the buttons, what's the number? And to realize and come up with a final view, you're going to be actually having to come up with this kind of a sketch, whereby I know I'm going to have this number of sensors, this number of switches, then these numbers of outlets. So this one is a very simple case whereby you only have 3 input devices, that is the start switch, then you have the increase switch, then you have the decrease switch. So these are the inputs, and then this is the output. So here we have, remember in the last video we talked about the momentary and the maintained switch. So this switch here is going to be a maintained switch, this one. And then the decrease and increase, they are going to be momentary. So the momentary switch, as I remember telling you, is a kind of a switch you place and it does not stay there. It comes back by itself. So even the programming of a momentary switch is going to be different. When you have a momentary switch, sometimes depending on which PLC you're going to be using, let's say you're going to be using Siemens, you have to do latching. That's for a momentary switch. You have to always have latching in your mind. When you're dealing with a maintained switch, nothing. You just have to have it there. If it's a normal open, when it is closed for good. But for a momentary switch, when you place it, it comes back to their initial state. So if you have not latched it, the system is going to just come on and off. Or maybe if you want it to stay on, you have to keep pressing the button. Think of you having a control panel whereby you're going to start a pump, and you have to keep pressing the pump forever until the system finishes. Let's say the tanks are overhead, they are all full, and then you have to press away. Or if not that, you have to have a maintained switch. So in this kind of a PLC, we have this is the sketch of like maybe the PLC, these are inputs, and then this is only the one output we are having. And over here we are, I have named everything. So this is just to give you a brief idea of what we are diving into. And then the major thing is here in the PC. I've just finished programming. I'm just going to take you through how it is done, and what each button is meaning, and how you can make your workflow, what is the environment we are interfacing with, so as you can learn everything by yourself. So let's get here. When you reach in this environment, you have what you have to first do is to go to the device comment list. In this device comment list is actually where you put these fellows. Like in device comment list, you come, there is X, there is Y, there is M, there is S. So X stands for input devices, Y stands for output devices, M it stands for the memory, whatever. Then when you go to like T, it's the timers and all that. So apparently in this program, we only have three input devices. We have the start switch, we have the increase, we have the decrease switch. So our start switch, we actually connected it to the X0 of the PLC, and the increase button, we connected it to the X1. And so you just come and put it here. Let me put them in upper cases. I will just come and put increase, and then here I put decrease, you know, and then here I will come and put start. Mind you, the program is already made. We're just doing it for the sake of practice. Then we only have one output device, which is here at Y. We only have one output device, and it is our LED bulb. So I go to the timer. I only have one timer. I just name it as timer, Then we go to D, the register, this memory register. So we are going to be using two registers. They are actually, I think for this PLC, they are around 7. I don't remember. I'll just confirm. So we store the total time. D0 is for total time, and the on time we stored it in D1. On time. So after doing this comment list, it will help you. I'll show you how it helps you. You come here down where there is a program. So if you don't have a program, you press here and you right click, then you press new. But actually, I already have a program, so it's here. I will just double click it, and this is how the program looks like. Let me just try to zoom in. So as we can take one network at a go. So this is the first network, and in this first network is whereby when our system starts, we want to shift a particular value in a register. We want to move a particular value, let's say like 20, standing for like 2 seconds, because actually here uh 10 means 1 second. So if I wanted to move 20 in a particular memory, this is the memory, I will have to use a move command. So this is the move command, but I want it immediately when the system is starting. At the start of the system, I want to just immediately move one command, move a particular figure. This is like 20, or someone can put 30 to mean 3 seconds, or someone can put like 50 to mean 5 seconds. So you come and you put this contact, and this contact you will actually get it from here. You will have a network like this, and when you press this and you come here, you press like this contact will come. So uh, the other thing is how you see how this, you try to see my cursor. You see the arrow. If the arrow is facing like, literally like it is it's facing the other side of the rail. There's that kind of thing, you can see it if you see very well. It will be meaning that whatever contact you place in that line, it will fall in the same, on the same line, not parallel. It will be in series. But if I change this cursor like this a little bit and it comes here, it changes to this form. You see this form from this to that. That means it will be parallel. So if I press here, it will be parallel, and if I press here, it will be in series, you see. So those are things you have to understand within here. But just let me take you through how the program is running. So when I come and uh, I have stored data. So I just came here, I stored 20, as in I stored 20. And where am I storing it to? I stored it in register D0. So these are things you put. So one thing to mention, whatever I put in the comment list, device list here, whatever I put here, if I at X, if I put X is equal to X0, I put start. This other side in my program, if I write here X0, I will just come, let's say I write X1 here. If I write X1 here, that means I will have changed the thing. Even this one has to change, because X1 is actually for increase, right? So if we put x1, you see it has changed to increase, but here it was supposed to be x0 for start. So for starters, those are things you have to understand here. So explaining how the program is going to be working. So if I put this network is just to move the total value of the timer, like you know what we want our timer to be running from 0 up to 2. Then I start my system. If I want to start, whenever I'm starting the system, I'm going to be starting with the timer. I'll have to initiate the timer to start operating, as we discussed previously. So here, I'll put a normal open for the start switch. So if I put the start switch as a normal open, one thing you have to visualize, if I press the start button, the timer immediately should run. So I come here, I bring, I can get it from here. You see, here you can get functions. You go to all and then you search for timer, timer. This is the function, When you bring this timer and you put it on this network, you come here, you will start now to, you have to label it because it has different timers. You can have as many timers as up to this PLC can accommodate. Let's say if it accommodates up to 7 timers, here you have used one. So you have to name it. I have used timer one. You name it timer one because in the device list, where in this comment list, where is it? Device comment list. We indicated we used only timer, this timer, and it is T01. So we can move up to wherever. So again, we move back to our program. So we indicate we have used timer 0. To how much should it count to? It should count to 20. 20. This 20, it is stored in this memory, D0. So at this D0, I have to, so when I put D0, this counter will be counting up from 0 up to what is stored in D0. And what is stored in D0, it is 20. So I go to another network. Then this network that I'm into, I have to store and some other data. I have to store some other data that is, actually not storing, but I have to determine the on time. Determine on time. See? So when I want to, how do I determine the on time? The counter is going to count from 0 up to 20. It's going to count from 0 up to 20. But I just want it to be on from like 0 up to 10. So I'll bring in the function of division. So as long as the start button was placed, it is on. Remember, it is a maintained switch. As long as it's on, I divide to get what is, for my time to be on. So when I divide, I will this here is the source total time in the timer. You know what is stored in D0 and divide it by how much? By 2. And whatever result I get, I now store it in memory D1. Remember, D0 is storing on the total time. Now D1 is going to store on time only. So if I store on time only, how am I going to use this? So I see go here on this network. Let me name it like to name it, you have to every network you can name it. It's like a comment. Uh, mm, Switching on. Let me put switching on the bulb. So how to switch on the bulb? I'll have to, this one, the start button has to be energized. And then I compare. So this is a compare, greater or equal to. So this one still, I also get it from here, where our functions are. There is comparison. So I'll move and I go here, greater or equal to. I'll get it from there. And then what am I going, the source, on time. Remember this on time we have here, I'm going to put it here because now this is where our time for the bulb to be on is stored. And then I compare with what? I compare with what the timer is counting. So when the timer when this timer is counting, let's say from 0, 1, 2, 3, 4 up to 10, it will be greater or equal to. So now I have to energize this side. I'll get the output. You understand? So once I get the output, the bulb will be on. So when the bulb is on, let's say now, because now here the bulb starts when it is off, the timer counts, and whenever the bulb is whenever the counter exceeds what half we had stored in D01, I mean D1, now it can be off, it can be on. So if I want to put the function of increasing the period, let's say it's blinking faster and I want to increase the period of the storage. So I have to incorporate the increase button. And this is the increase button. Still, we get it from here. And once we get it from here, we just come and we put it here. Let me show how then I name it like X1. Once I name it X1, it will show increase. And once it's showing increase, one thing you have to understand, if it is showing increase, we have to it's not a maintain button. It's actually a momentary button. So I have to press here and I press the space. So I put rising trigger, a rising trigger signal because I'm going to press it and it comes back. It is not like a toggle switch, you know. So now once I press that, on increase, I will add in the total period. So let's say if I add, I want to add it by 1 second. So I go to B01, the source which you want to add as the total time, and then I add what? I add 10, and I store in the same resistor, D01, This the same for reducing. If I want to reduce, I will do the same. The decrease button is X02, X2, and then I do the same, but for this time I subtract because I want to reduce the time. I want to shorten the time. So I mean this is how it is. And then at the end of the time, when that cycle is complete, what I have to do is when the cycle from 0 to 20 is complete, what will happen is that we have to restart the cycle again. So once we want to restart the cycle again, we have to, if we have this normal open contact we put for the timer. Now the timer will be shown once from 0 to 20, the timer signal will go up. So once it goes up, this one we put a coil for the output for the timer as well. And then we here you just press space and then you reset it. This is how we do reset it. So friends, this is how the program is running. I know if you're new here, it might look a little bit complicated for some reasons, but as time goes on, as we do more examples, it will be one more easier for you to understand. So in here, if I want, I can simulate for you the program here to show you how it will be lighting up and all that stuff. But that means I have to compile here. Once I compile the program, they are showing me zero errors, zero warnings, and everything. That means everything is okay. So I can run the program. Just let me download it in the PLC. I transfer in the PLC. Here I'm running the program. So I need now to run the PLC as well. I run the PLC. I put it online. Here I put it in online mode, and then I set MPX enabled. Yeah. So here we want to see. So friends, in this video, actually, for me, I did human machine interface. That is HMI. It's not mandatory for you to do it right now. We have to first understand the principles and everything, how it's working, how it's operating. And then at the end of the day, you will also be as well able to get to human machine interface. But for more reason, most times you find people are not doing that. Some applications you don't need HMI or whatever. So I just wanted to do it for the best of you guys to see. Um, I designed it over here. This is the screen I designed. I compile as well. Once I do the compilation, uh, uh, offline simulation. So this here is the screen. It's actually good to show everything what the program has been about and what the screen is going to in real world. So here we are dealing with the real world. So here we have the start and stop. We have the increase button, we have the decrease button, we have the LED bulb, and we have the on time. So can you guys see? Like I want us to get it from here, like from the very start, you know. Uh, so here, if I press the start button, if I press the start button, the time on which I have designated for my bulb should be showing. Like let's say it is 10. So since I stored 20 in the system, that means 20 divided by 2 is 10, and that means the on time display will be showing me 10. So if it will be showing me 10 and I want to increase it and I press like increase by 10, that means 10 divided by 2, so I will have increased the 5. You understand? So here, let me actually run it and we see what we shall be getting. So if I press start, if I press start here, this one should react to it. You should see this one energized, and you should be seeing the timers counting the values, and the value here will be showing. So if I press start, you can see the start button has been energized here, and once this one is energized, the timer starts operating. And once here we divide, we can see 20 divided by 2, we are getting 10. 10 is stored here, and the bulb is actually giving us the light. 1 second beat, 1 second out, 1 second in, 1 second out. And let's increase the duration of it being there, being in a stall environment. It's not changing. I will increase. Remember, when I increase, now here I have increased by 5, so it has to go on 5. You can see it here. And I want to increase more. Now it has to last for 2 seconds. Now it is getting a little bit slower, to show you how it is operating. Here, the program is showing you how everything is. Now we are sorry, 20 is here. So if I want to decrease, I can decrease as well. I can increase as much as more, now 30. If I go to 50, 60, those are 6 seconds. Now you can see how the bulb is waiting. 6 seconds. We shall 1, 2, 3, 4, 5, 6, and it goes up. So with me, you can catch up with me. You can ask me any questions. If you ask me a question, I'll be replying to you with a full video to about everything. It might not be easy, but it is very easy actually. PLCs are very easy. They are enjoyable, and they are actually next to our doors in the real life world. So catch up with me. Let's keep this together. If you want to ask me anything, just comment on the video. I'll be checking up, and I'll be giving you responses. All right. Goodbye.